at k plus 2. Now, that means that y at k plus 2 is equal to CD AD x at k plus 1 plus CD W at k plus 1 plus V at k plus 2, which tells us that y at k plus 2 is CD times AD. Now x at k plus 1 is AD x at k plus omega k plus CD omega at k plus 1 plus V at k plus 2, and therefore finally y at k plus 2 is equal to CD AD squared x at k plus CD AD W at k plus CD W at k plus 1 plus V at k plus 2. Now you can see that we can continue to do this on and on and on, right? Until we got enough of them to let us write what is the generic formula that applies for any index. And it turns out, and you can probably see it, I'm looking at my notes here, and when I did it with the notes, I did one more. I did y at k plus 3, but I think it's not really necessary. You can see how to do it. If you had to do it, you could do it. And what you eventually find is that y at k plus I is equal to CD times AD to the I times xk plus the summation from j equals 1 to I of CD times AD to the j minus 1 multiplied times omega to the k plus I minus j plus V k plus I. So this is the equation I find for what is y at k plus I. Okay? Now, once we have y at k plus I, we want to say what is y at k multiplied times y. Let me see, which order did I use just to make sure. No. Y at k plus I multiplied times y at k transpose. What is that equal to? Right? So it is just going to be that expression. I'm going to have to erase this to give myself a little more room. So y at k, again, we know y at k is CD x at k plus b at k, right? So we want to multiply this thing times the transpose of this, and the transpose of this is xk transpose CD transpose plus bk transpose, right? The multiplication of these two things follows. So let me erase this and this just to see this as a multiplication. Like that, right? And so we see this times this, and so we get CD times AD to the I times xk times xk transposed times CD transposed, right? That's the first term. Now, I could write all the terms, but what we're going to do is to take expectations, right, of the product. So might as well, in order to keep the board cleaner, instead of writing them and then saying they are 0, let's see if we just simply see what is 0 from the outset and just not write it into the expression, right? So here it is. I took this times this and I get this. Now the next one is to take this times this. All right? Now it's clear that the measurement noise doesn't affect anybody and it's white. Therefore, this times this has an expectation of 0. So we're done with the first term. Now we go with the second term, which is all of these guys multiplied times the first one here. Now, if we look at the indices, we find that WK is never, well, WK plus I minus J, right? This is always at or ahead of this. Therefore, what did I say, ahead? No, there is never any, for example, let's say we take J equal to 1, right? So K minus 1 plus I, and I is whatever the power that we're looking at. This term is, like we argued before, uncorrelated with xk. Wait a second, let me see if I can state it even clearer, because I know I've argued it before. WK, the only influence of WK on XK, I mean WK cannot have an influence on NK, but WK could have an influence on AK plus 1, so W at K minus 1 could have an influence here, right? But is there a K minus 1 here? No, because K minus 1, there's always a plus I, so this is always never correlated. Therefore, this term times this term is 0. This term times this term is clearly 0. These two white noises have nothing to do with each other, and we're done with this summation that doesn't do anything. Now we come to this term, Vk plus I times this is clearly uncorrelated, and Vk plus I and Vk transpose, this is white noise, so it's uncorrelated unless I is equal to 0. Okay? So if we say I is not equal to 0, then this is it. Okay? So if I is not equal to 0, the expected value of yk plus I and yk is this term. So I will write it here. Sorry about the fact that this doesn't look any stronger, but I can't find anything stronger right now, but do my best here. So let's see. The expected value of yk plus I times yk transpose, we're going to give that the name delta sub I. And that has been shown, unless I is equal to 0, to be CD multiplied times AD to the I multiplied times, what is the expectation of this? xk transpose is sigma, the covariance of the state, and then CD transposed for I not equal to 0. For I equal to 0, we have delta 0 is equal to CD I to the 0, which is 1, covariance of the state, CD transpose, and then we have to add the expected value of Vk transpose, which you had previously called R. Okay? So this is it with the output, right? Excuse me, got a call.